Hello, and welcome to the latest installment in our UXDX online series. I hope you're as excited as I am for the talks that we have this evening. But before we jump into those, I want to give a really quick introduction to UXDX and why we host these sessions. So at UXDX, we have this kind of saying that the world is full of bad software. And I don't mean software that doesn't work. I mean software that's clunky and difficult to use. And I always use the example of a banking app. I have a digital first native banking app, and I have a very traditional banking app. And they technically do the same thing, but are worlds apart in terms of usability, and therefore which one I'll reach for and use. And we don't think that that's down to the motivation or the skills of the people involved, because there's incredibly motivated and skilled people everywhere. But it's down to the environment that you're working in. So at UXDX, our mission is to help companies build environments that can't build bad software. And how we try to go about that is by shifting away from waterfall projects to empowered autonomous product teams. Now, that's really easy to say, and it's really hard to do in practice. And none of the talks are going to cover entirely how you would try to do that organizational change. But what people are going to share is how they're improving and iterating in their part of the process and how they're making changes. And hopefully, as you're listening to the talks today, you'll think of some questions that you can ask to dive deeper or expand on some of those topics. So at the end of each talk, we'll open it up for questions. So please feel free to write those in on whichever platform you're watching this on, and we'll ask those questions through to the speakers. But that's enough about me, so you're not here to listen to me talk. I'd like to introduce our first speaker for this evening, who's Juhan Sonin, who is creative Sandpaper at GoInvo. And Juhan will be talking about design for action. So I'd like to welcome Juhan to the stage. Over to you.
Hello, my name is Juhan. I pretend to run a design business in the Republic of Boston called GoInvo, and I teach at a private equity firm in Cambridge. Because I'm talking about healthcare and software, which are all political, it's nice to know what my motivations are or what they're not. So yes, all my health data, including my entire genome, has been open source, so feel free to plant it in a crime scene somewhere. If you want to get a hold of me, I will try to get back to you within a few business hours. Just email me, yell at me here, or in public. I'm easy. So, look, a lot of engineers, of designers, of clinicians are struggling. Here in the United States, we've had this weird funding spigot with the Fed. It's been really strange, but I get this question a lot. I want to have an impact on healthcare. Okay, so how do we go about do it? Where do I go? Now, there are a metric ass ton of options out there. These are just a handful of them. So that's also daunting. And at the same time, just on Sunday, I happened to be at the Camden conference, and I heard this from a really good reporter who's covering the Middle East. And it's like, hey, I'm a journalist. I don't have solutions. I've heard this too from the designer engineer world that says, hey, I'm a designer. I don't have a point of view. Well, okay. But part of this is, haven't you seen potential solutions, or, have you reported on them? What's your research suggest that we do? But the idea is, okay, yes, we're probably overwhelmed a lot, but the gist has to be, let's get in the game. So by doing that, you can just start making stuff. And that's, that's what I tried, at least maybe screwed up on at the beginning, is I'm like, okay, how do I see my own health? This is some time ago. This is how I got into the field, because I went to one of these little nursing stations at a company I was working for at the time and had my cholesterol checked. And the nurse looked at me bug-eyed after she saw my results, going, how the hell are you a functioning human being? Well, I'm like, oh, maybe I'm not. But this got me started on what the hell is happening inside of me? Where's the dipstick? What's it saying? And this, started the health card. This isn't anything magical or anything like this, but this is, a few decades ago. And so this is what I sort of plopped out after some trial and error. And it's sort of funny is like nobody asked for this thing. Nobody, just me, my brain. Nobody in the department funded this. I was at a bigger company at the time. we just started to make it. Now, I started bringing it to all my clinical visits. I had it in my pocket all the time for years, actually. And what was the interesting part of this? Maybe for others is it was open source. It drove inputs to some of the software we were going to make, or that we're about to make at the time, and we used it as a validation service. Is the health data that we're capturing, right? Because we could render it. And ultimately, it started other projects. Now, it's funny, is like I was walking around Quantified Self Conference, like the number 1, number 2, and someone recognized my mug from that, and they actually used it at WebMD to validate their patient reviews. But then we said, okay, well, how do we operationalize this? What kind of data inputs do we need? And so we actually made a prototype. This isn't glorious, this isn't remarkable, but we started, how do we make this thing real? And look, the 3 projects that sort of came around during that time. One was a U.S. testing service, entire nation testing service for electronic health records. It's called Leica. Another was HData, which eventually was folded into the small and consequential thing called FHIR for the planet, data API, or how to make data more accessible to everybody and systems. So, but these 3 little projects nudged a whole bunch of others. Not at a huge rate, but they had some tangible nudging for bigger national plays. So a lot of other projects also germinated from these 3. Apparently, I'm good at designing logos with circles, but that's what happens. Projects can begat other projects, and even if the first one's not great, like my health card, it drives other potentials. So my hope to you is, to all of us, is, hey, we make stuff, we ship stuff, we hopefully publicize or open source it, depending on what kind of license you want to use, and you're planting the seed for others. And ultimately, this starts to drive your own agenda. So healthcare is really risk averse. Hell, the city of Boston has become so tight in around the healthcare space because all the money involved. It's gotten even more risk averse. The lawyers, their job is to say no, and look, healthcare is lives on the line. So it begins to say, this is hard by design. So the first thing is to break through some of this is stop always seeking, approval, because the first thing, your colleague, your manager, the department head, the president's gonna say no. But this somehow, for the species, occasionally evokes paralysis, like, oh shit, we can't do this. So for great ideas, for your interesting stuff, you have to see no as yes, because they're gonna keep saying hell no. So you just got to start. You got to make stuff. And don't wait for consensus. It doesn't work. Design requires judgment and direction. You just got to go. And by the way, this is a little side note, is the more ideas you have, even a ton of crappy ones, the potential for having better quality ideas is validated to be true. You can look at an MIT study here. I can forward this, my slides at the end so you can see it. But the more ideas you have, the bigger the count of good ones in there. So, one dumb example of that is when we were doing HData, this data standard. How do you put your information in code that led to standard health record? Well, we were thinking about cancer and like, okay, it's the first, second biggest killer in the United States and the planet, along with heart disease, and we're like, what can we do in a week? What concept can we start to generate in a week to say, okay, this is something worthwhile for our R&D tax dollars? So we just put this together. It's not great. In fact, the graphs drive me bananas because I know they're fake. But we put a couple ideas together of what could we do to prove that having structured data for cancer and for patients and clinicians could actually do good. And so what happened is we got this together, and all of a sudden it begat a whole bunch of small projects that turned into big multi-million-dollar projects over the course of the next year. So a week or two seeded much bigger projects. I can go into these at some other point. If you have questions, just let me know. But the idea here is you have to fight for good ideas. You have to start fast, make something that could be usable, be willing to change your tactics, because these things don't stay the same when you're making them. You have to get feedback and move them. You know this too as a designer or engineer. Ultimately, those little screenshots I showed, completely different than the thing we built a couple times over for several cancer institutes here in the US. And then you have to never give up, really, hopefully, and keep pushing through and make sure your ethic is there. Now, many of you probably have heard of Gropius, the architect. And after he moved from Germany to here in Massachusetts, he taught at Harvard, and this was one of his graduate student buildings that he made. And there was this classic line when he was interviewed about it in the Harvard Gazette from one of the reporters, and they asked him, "So why did you bolt down the furniture in all the dorms?" And his answer, he looked quizzically at the reporter and says, "Well, why on earth would you want to change it?" That's insane. But also there's some greatness there, but totally insane. But the idea that, okay, sometimes his ego got a hold of him. Sometimes it happens to me. But if you don't give a crap, that's what really kills projects. So, okay, ego sometimes gets in the way, but if you don't care, what the hell? So why am I mentioning this is you have to start caring and fighting through the BS, especially in industries that are regulated like healthcare. So in this log to create sort of beautiful things here, you also need to think about your products, who's going to use them, your own team, and your city, your state, your nation. And one project that we happen to work on that involved all three slices of that, from local towns to the state to the nation, is we worked on food stamps. This idea where if you earn a certain level or a poverty level, you actually get some reimbursement for your food. Sounds pretty basic. Most civilized countries on this planet have something like this, but we started to make it. We made a service and shipped it from Massachusetts, and we had to fight with the lawyers, fight with the policy wonks to, drop how many questions you asked. It was a long, arduous task. But after we shipped it, at the beginning, only 7% of any Massachusettsian, someone who lives in Massachusetts who qualifies, did it online. But after a few years only, now 70% do it online because they can do it from basically a dumb phone and get it shipped to their house or walk in and get their SNAP card. That's a pretty remarkable service that is an example of how do we work with our towns and cities to make something a little more elegant. I'm not going to show the design because the design is pretty straightforward. But what happens too is you can think about more than just your initial problem set like food stamps and think about, well, how do I then think about applying for all the services that I qualify for? Why don't they just come to me? I mean, if we're in the country of Estonia, this already happens, where if you sign up for being a resident there, all of a sudden automatically it shows up on your phone what you qualify for, what you can get. But here in Massachusetts, that's not how it works. But we had to fight for this over time. We had to say, well, look, all these services should be connected and you should automatically get all these things coming to your phone. It took years for us to fight for us. And it's not just us fighting for this. It's other organizations who are doing the bulk of this, advocacy groups. But we had to start somewhere, so we started making it. Now, when you're dealing with national or state services, you also have to think about, well, how do we change the law? Now, what laws are there? What should we be doing? What's your point of view on the law? And so here are mine. You're not going to agree with all these, by the way, but it allows me and the design studio that I work at to say, okay, what do we pick and choose to work on? And so we all have our sort of points of view. Not all of us are agree, but we can agree on the things that we want to jam on in an open source fashion. So these are a few of them. But I think this is a really good exercise for you and for all of us to say, what's our agenda? What's the law we want passed? Easier said than done. But you have to show up. You have to have this kind of agenda. And, we publish all this too. As a studio, we say, okay, we need to keep ourselves on the line. So we publish it online. We say, this is what we're going to do. Maybe sometimes we break it and we have to change plans. Okay, shit happens. Having a national federal health agency about literacy, maybe it's fantasy at the moment, but we'll still fight a little bit for it. So we publish and we work on this. So we say, hey, look, if we're really interested in owning your health data, I'm wearing one of my health data shirts, own it, is what do you start with? Well, do a little research. So we wrote a position paper, actually 2 of them. We get it published. We write an open source graphic novella. You can download it at ownyourhealthdata.org. Okay, and we publish it, and we seeded a small piece of legislation for Massachusetts. And what do you do after you seed it? Well, you send it to some representatives, which I've done. I've sat down with my local representatives. How do we get this sort of on the docket for Massachusetts? That's a longer play. But it also doesn't just start there. Usually you want to team up and figure out what other design or engineering or policy firms or healthcare firms are doing this. And so we worked with several organizations to come up with, hey, what's a draft patient data use agreement? It's like a contract between you and the clinician or the clinical teams that identify who owns the data. We came up with some prototypes, and in parallel did our position papers and graphic novel. So this is part of how you think about it, or part of what we've done in this particular case on policy. And then you always want to start with the end in mind, right? So if you want this idea of, hey, you step on US soil, you step on X country's soil, you get healthcare. Okay, so how do you get there? What are the steps to get there? Because here in the United States, it doesn't just happen. There are these incremental components. So maybe, you think about what are these ways to get there so that you have a path to perdition. This happens all the time. Well, I don't want to get into politics and all this kind of crap. Yeah, but the problem is, what happens if you don't, because the CEOs of these companies are going to take advantage of you basically in egregious ways. Have seen it over time immemorial. It's become more hyper-focused now because everyone's like, they won't even bother fighting us. Oh, we'll tweet something, or Twitter's dying or whatever it is, but we'll put up some banner somewhere. Oh, that's our way to fight. Okay, it's a start, but big companies don't see it that way. So for me, it's like, hey, you have to have an agenda and do it multiple different ways. And one way is to think, well, let's pretend for a second we're not at the Harvard Business School where finance and money is the center of the earth, but actually more like the pace layering that Stuart Brand has, where what am I trying to show here is that things at the very periphery of this move very quickly. And as you dive deeper and deeper and deeper, it gets harder and harder to have influence on it. So in design world and fashion, some of our work, it moves fast and changes a lot. But as you go to commerce, as you go to infrastructure or culture, these things take a lot longer to move the general public on. And so this is the way I sort of like to think about why you should get into the policy game, or at least thinking about it, because it's really hard, but it has enormous impact once you pass something, hopefully for good. And that's, one additional way, other than just designing and shipping things, to how you can sort of expand your impact. Now, you also have to think about what's the system of this. And so, I put together some of my position pieces for the U.S. again, you're not going to agree with these. In fact, I have a whole bunch of new ones, especially over the last 6 months, with things going down strangely here. But I publish these as well, so there's nothing I'm hiding here. Not all of these are right. But the idea here is, what's your agenda? You need your own policy list. So, hey, this is what we're fighting for. This is what we need as a city or state. Ultimately, actually, we need a policy Mad Lib service, but it's a separate little problem. And, you know, I talked briefly about an eligibility engine. You know, how does a state or country automatically take and give you benefits that you qualify for? Well, we've worked quite a bit on this. And even though the state at the time, Massachusetts, wasn't into this as much, we came up with a position piece. What needs to happen? Why it needs to happen? What would it act like? What would the policies need to be? We even came up with, what are the common data elements for being a resident of your country or your state? This is not an easy problem. And so we came up with a list. And finally, I think Massachusetts now is prototyping and has a draft of this, working with Medicaid, Mass Health, and food stamps, which is fantastic. Not that we, you know, forced them into this, but at least we had a position and we published it and open sourced it. My hope is that other states follow. Now, what's again, because I live in the U.S., this is actually pretty great, is that there was a non-binding vote. You have to start somewhere, on whether single-payer healthcare, universal healthcare, should exist here in Massachusetts and in the country. And Massachusetts had this on several ballots across the state a year ago, and it was unequivocal that people wanted this. Republicans, Democrats, Independents. 65% said yes. And that's, you know, usually it's 51, 52, 53%, but you have 10 points, 12 points higher than that. Clear signal. Now, when I talk about also the Own Your Health data, you know, it's nice to see also other people getting involved. So MITRE is a nonprofit company here in the U.S. That actually put this in their strategy for the company. That's pretty rad. It's not exactly a right or left leaning organization that's particularly aggressive. So they put it in there. That's pretty great. But, you know, now you think about, well, is owning your health data a top 10 healthcare problem? Well, probably not. Maybe it's top 20. Yes, we've made a list of what we think the top 20 or 25 list of problems are here in the U.S. Based on what the impact is to patients and humans and how much money is at play. You can see that here at U.S. healthcare problems. But do you have your own? What's your top 20 list for your town, for your state, for your nation? I don't know. We probably need that. And guess what? We're working on a prototype, another open source project that begins to look at, well, what are these things? How do you know people agree with you? And then how do you begin to synthesize or know that people are going to agree with this over time? And so we have a prototype here. It's on GitHub, by the way. It's just evolving. If you're interested, you can give me an email and see early concept here that we're just sort of brain farting at the moment. So to wrap up here, when you're designing for action, you need to just start something and make it and ship something small, something that says, here's proof of life. You have to sort of live the problem. You know, with my health card, I sort of lived with it for a couple of years. It became something that many of us in the department started to use. And that means bringing it to your clinician, bringing it to the environment, the scenario that you're planning to design for, that you're engineering for. And then ultimately you need some stamina, because working in the civic space, working in the healthcare space is not something where just because the machine can poop out an app in an afternoon with you doesn't mean that uptick in workflow is going to work for everybody. Sometimes that can take weeks, sometimes it can take months, sometimes years. So this requires a kind of, I'm going to fight for this over time. That's not sexy. It's not always fun. In fact, there's very little fun. It might be 3.1415% fun. but you got to fight, and this is over the long now. Look, it's complicated. Healthcare is messy. It's hard to make beautiful. But my hope is, like American democracy, healthcare is resilient and will fight back, bounce back. And what you make today is obviously, or maybe not obviously, is going to look a lot different than maybe what it manifests in a year from now, in 5 years from now. But you have to start. You just have to start. I've stolen from all of these people here, and they have given me critique over the years. And this is my email address and phone number. Feel free to publicly shame me at will, or just give me a call. You can download this talk too at designagenda.org. Thanks very much.
Excellent. Thank you very much, Juhan. That's I think it's the first time actually on the closing of a talk I've seen somebody put up their phone number. So we'll see whether you get any phone calls as a result. But yeah, thanks very much. I really enjoyed the kind of the framing, because I haven't done, I've worked a little bit in public sector, but not as much experience as you have. I've worked in some very slow corporates, and I know the same of fighting for what you believe in. But I'm going to ask, my first question is just really around, I think it looked really impressive how you have all of your policy decisions. But for me, where I was thinking when I was looking at that is, I don't even know where I would start on that. I think that it's an incredibly valuable thing to have, but there's so many unknown unknowns for me around the law, around the existing policies. How did you go about, I guess, setting that up in the first place? Because I believe, as you were explaining it, that's your driver for everything from there on.
Well, it's one driver. And it wasn't a panacea. It didn't come to me in a fabulous dream after, having a lot of mushrooms and ODing on cocaine, although it may feel like it. I think you have to grow into it. And so it started with me just, when I started with the health data side, there is no health data standard for the United States or, country of choice. And I started with a couple, and that got me into it. And go, my God, why don't we have this? Why don't we have this? Or what's happening with this? Or this is totally foobarred. And then there's another, right after I had the first 3 little policies, not so little, that helped our work too, because it was like the culmination of those early prototypes in healthcare. It's like, my God, there's no health data standard. Okay, how do we get our health? There are some rules like HIPAA here in the U.S. It started small. So that's my answer, is like, Roy, it started small. It wasn't this huge, like, massive policy list at the beginning. But then it has evolved over years to say, okay, this. Okay, now I'm more interested in this. And then it began, and now it's beginning to say, well, how do we do this for the whole U.S.? And you can use, there are other services out there that you can say, oh, this can help me figure this out. But sometimes it's just things that affect you too, and you start to think about it. It's like, you have to start somewhere. And so start small, start with things that impact you.
Excellent. And I guess the other thing that people might be thinking of, because yes, I know bureaucracy, I know all of these problems that I'd love to solve. Where do you carve out the time, and how do you make this a priority when there's a million other things that are going on with work, with life, etc.?
I think you just have to make time. They're just like, well, how do you do it? I mean, we live in a fantastic time where time is becoming more of a good thing for people. We're not toiling in the fields. Most of us here on this, in the digital space, are not wiping ourselves out completely. And how much time do you spend doom scrolling? Right? Not you, Roy. I'm not. I'm guilty. Carving out 20 minutes of a day to say, I'm going to focus on, hey, I'm going to write these 2 paragraphs. I'm going to draw this diagram or whatever. You can do it. If it just requires a little, stamina. Even 15 minutes a day. It's like if you're learning to play an instrument. 20 good minutes a day, way better than like 3 hours of bullshit once a week, right? So that's but it's up to you. I mean, how do I answer that? It's really how you adjudicate your own behavior.
Brilliant. Well, that actually brings us to time. So I just want to thank you, Juhan, for sharing. It's really inspiring. It's great to see that there is progress happening, even if it feels like progress isn't in some of these spaces.
Oh, we're going backwards.
We're going backwards. So it is great, though, to see that there are people out there pushing it. And thanks for sharing your advice with everybody.
Thank you.
Great. I will move on to our second talk for this evening. So I'd like to introduce Bianca Work, who's the founder and principal at Alvio. And Bianca will be talking about designing, developing, and evaluating AI native product ecosystems. So over to you, Bianca.
Thank you so much. So, hey everyone, I'm Bianca. Today we're going to be exploring how to adapt our deterministic product thinking and practices to AI systems that behave in a probabilistic manner. So, most of our design, development, and evaluation techniques currently assume stable outputs and defined flows. But with generative, agentic, and predictive tools, that introduces variability and drift into our product environments that we need to account for. So, when that's the case, our responsibility as researchers, designers, PMs, and engineers really shifts to defining what is that acceptable variance that we can accept in our environment. How do we enable those guardrails in our code to make sure that we're still delivering the right thing in parameters that make sense? And how do we start considering how we detect drift and fit and accuracy proactively before the outcomes that materially matter to us degrade in a really meaningful way? So, over the last 5 years, I've built enterprise performance and experience measurement decisions at companies like Indeed and Splunk. And that was where I really helped them to unify sentiment, telemetry, and behavioral data into operational product health and intervention models. And today, through Alvio and the advisory work that I do, I'm really focused on turning the fragmented and disjointed signals that we have into decision infrastructure that uses this predictive modeling and causal inference as its power. So this talk is really going to reflect what my experiences are and how to architect resilient, stable, and decision-ready AI native products. So one thing to keep in mind is that deterministic flows assume repeatability and optimize for correctness against a fixed state that we've predetermined. And unfortunately, AI ecosystems don't necessarily behave that way. And instead, they operate as evolving distributions where variance, time, and the layering of tools and outputs will continuously reshape the quality and the outcomes that we can expect. So if we were to design, develop, and evaluate this through a deterministic lens and the traditional metrics that we rely on today, we're really going to miss the things like drift that erodes our calibration with that machine, the alignment between the system and the user, and the decision quality that comes out of it. So today we're going to start by examining where this deterministic thinking and practice falls short for AI products. And then I'm going to introduce SHIP, which is the framework that I've developed to address the key tenets that matter most for these probabilistic tools. They're really thinking about things like the system reliability over time and context, the human understanding of what is happening and what they're looking for, the interaction design between that system and that end user, and then the product instrumentation that we put in place to understand the performance and experience as it goes. And then lastly, I'm going to walk through what this means to design, develop, and evaluate AI tools using SHIP. And if we have some time at the end, I'm going to close out with how to apply SHIP in your own generative, agentic, and predictive workflows too. So for this talk, we're going to focus on 3 of the most common AI capabilities. Generative tools usually produce context-sensitive outputs that are drawn from learned distributions. And this is where quality really exists between bounded ranges that we've defined rather than a single deterministic state that we can predefine. On the other hand, agentic tools will deploy actions across workflows and systems of record for us. And performance here is really dependent on explicitly defined guardrails, validation rules, escalation logic, and recovery pathways that we have in place. And finally, for predictive tools that do things like score, rank, or allocate our attention over time, we really need to be mindful of calibration shifts, distribution drift, and segment divergence, because this can really alter the reliability and allocation that we put into our effort in a way that traditional metrics won't detect when things are wrong. So I'm going to ground this in a real example. Imagine that you have an AI native CRM platform that sits inside a B2B SaaS org. A sales rep might open their at-risk account and the system will generate for them a renewal narrative. And it will automatically then adjust that rep's outreach cadence based on what that narrative says. And in addition to that, it might surface things like churn or expansion probabilities to help guide that rep's prioritization. As you can see, each layer of this workflow and interaction influences the next, with things like the narrative framing and shaping the rep's urgency to interact. The workflow that triggers can amplify their next actions that they take. And the predictive scores that are surfaced to them might reallocate their attention and priorities to the wrong place. So, with a deterministic lens, everything might look healthy. But over time, we can see sometimes that the generated summaries might become more certain than evidence purports, or a human might override the amount of times that they're using that tool and it will increase because they're not getting what they need. We might even see that there's a disproportionate attention being focused on the wrong customer segments to begin with. So ultimately, this can compound because variability was never really factored into our design, and guardrails were never enforced during our development process, which means that drift and fit are never instrumented for evaluation. So in this section, I'm going to expose where deterministic assumptions collapse in layered AI ecosystems like our case study. So in deterministic systems, typically variability is treated as noise or an edge case, an exception. But in AI native ecosystems, we really have a different operating reality. And that's because this variability is inherent and our outputs exist within ranges, and our confidence is therefore conditional rather than predetermined. And because this behavior will unfold across things like time and interaction, our definition of quality really needs to depend and expand on things like resilience, recalibration, and drift detection. And if we were to apply these linear flows or traditional metrics to these tools, we'll end up missing the indicators that really matter most for the performance in this context. So failure in AI native systems usually will show up in a few different ways. First, we can see small calibration shifts will alter the prioritization of next actions that we take. We can also see things like high value opportunities or priorities receiving less attention than is actually warranted. A consequence of that could be human override or regeneration rates that increase the decision cycles that we have and lengthen the time it takes to intervene. And ultimately, the teams that are relying on these tools might second guess the outputs and find workarounds to using them entirely. And what that means is that confidence in the tools will erode before our traditional performance indicators drop. And the cost here really is slower adoption, misallocated effort, and growing operational drag once these tools are no longer reliably trusted. So in a layered multi-stage AI product evaluation system, we have to think about how when we evaluate these things, they can't be point in time or binary. And this is because the lagging metrics that we currently rely on ultimately confirm damage after it happens. And what it means is that it misses leading indicators like confidence drift, workflow prioritization shift, and narrative distortion upstream. And that means that our evaluation needs to evolve to be able to monitor these things longitudinally, track their amplification across layers, and measure the alignment between the system and user over time and interaction. So let's make this concrete inside our ABCRM case study. In our compose workflow, the summaries might remain plausible for most accounts, but regeneration attempts could increase and expansion signals might become less prominent for at-risk profiles only. As that connects to our orchestrate tool, the workflows will then perform generally well, but rep overrides and escalations might cluster in pockets of end users. And that connects to our proact tool, where global prediction accuracy might remain stable, but account rank volatility will rise within just one subset of users, like top enterprise only. So now that we've examined where this deterministic thinking breaks, we really need to think about how to apply SHIP to address these common challenges that we're experiencing across generative, agentic, and predictive tools. And when we think about SHIP, that we really are factoring in the things that most influence probabilistic tools like system reliability, human understanding, interaction design, and product instrumentation. And together, they're going to enable us to design, develop, and evaluate these things in a way that traditional approaches don't. So SHIP really helps us to operationalize 3 commitments: that we design for variability, we develop with statistical confidence, and we evaluate for drift and fit over time. It's really for teams that are responsible for production systems where generative outputs will influence our decisions, agentic workflows will trigger our actions, and predictive models will allocate our attention and resources. You can use this framework before you launch, during model or workflow changes, or when your model confidence, allocation of effort, or user behavior begins to feel directionally unstable and misaligned from our key global performance metrics. So in this context, system reliability really matters because generative, agentic, and predictive systems will behave within ranges rather than predetermined paths. And those ranges really need to be defined, enabled, and aligned to human motivations and expected outcomes. And that's where we bring in human understanding, because our users will have their own mental models and goals and will interpret certain uncertainty, risk, and automation signals differently from one another and have different tolerances from one another. And that's really why interaction design ends up mattering, because the variability that occurs without structured recovery, override, or escalation pathways will turn that minor instability into really realized operational friction. And that's where we bring in this lens of product instrumentation, because it will allow us to account for things like the shift in distribution over time, the drift in confidence that we see in our models, and the signal amplification that needs to be detected longitudinally before our outcome metrics degrade materially. So in this case, system reliability really defines and maintains the acceptable ranges that we can expect out of our tools to create the sustained stability and model performance. So in deterministic systems, reliability is often produced through the correct output along a nominal path. But in AI ecosystems, that output stability really needs to be explicitly defined, calibrated, engineered, and monitored. So in our case study with this compose tool, this means that we need to end up specifying the acceptable narrative variance that can exist across prompt and context and window, so that the language that we're relying on does not gradually shift towards overconfidence or inaccuracy. Something to look out for here if you're creating these types of tools is that if regeneration attempts tend to cluster within a cohort of end users or account types, or if we're seeing that our model confidence shifts over time, that's a really valuable reliability signal that we need to pay attention to and are not capturing in our traditional metrics of performance. With human understanding, we're really calibrating the perceived reliability of the system's behavior with their end users' goals and the actual performance of the system itself. And this means that the reliance on this needs to remain proportional to the risk at hand. And it's not just driven by a recent experience or isolated error only. So in deterministic ecosystems, interpretation is often simplified because outputs are discrete and predefined. But on the contrary, in AI systems, those outputs are usually uncertain, vary, and have downstream consequences. So in our case study with this orchestrate tool, human understanding will ensure that the automated actions are interpreted at an appropriate level of reliance, given the uncertainty that exists and the risk profile associated with it. So think about it. A single high impact false trigger for a sensitive account can shift a rep's behavior immediately, even if that aggregate trigger performance remains within our target thresholds for most cases. And here we really need to start thinking about things like override frequency, escalation pattern clustering, or if teams are introducing informal validation steps before acting on this, because these are really calibration failures between the system's confidence and humans' expectation of output. And with interaction design, we really want to preserve clarity, recovery, and agency when the system carries uncertainty, because oftentimes humans will adapt their actions to ambiguity and unexpected outcomes in ways that we cannot anticipate. So, traditionally, in deterministic systems, that design usually optimizes for uninterrupted flow. But in an AI system, that uncertainty must be made visible and containable in a really meaningful way. And that's because if a tool were to limit or hide or misrepresent, the user will end up compensating by slowing down, double checking, or bypassing the system entirely. So, in our case study with this ProAct tool, interaction design here will really expose the threshold controls that we need to consider, the confidence context that we need to emulate, and the scenario sensitivity that we need to account for so reps can understand how these small shifts in our tool's ability to compose, to act, and to predict will alter their next actions. So if our end user ultimately can't adjust these thresholds or inspect that sensitivity or interrupt that automated ranking logic that we have in place, it's very likely that they'll introduce manual overrides or shadow decision processes that will operate outside of the tools that we've provided for them. And lastly, with product instrumentation, this really requires continuous signal detection and adaptive recalibration, and that helps us to avoid compounding misalignment across tool, interaction, and time. Traditionally, we're usually tracking static KPIs that are defined at launch with a deterministic system. And success is usually measured against fixed benchmarks or investigations happen after the outcome metrics are declining. But in AI systems, instrumentation really needs to monitor for leading things like variance and dispersion and signal amplification before those outcomes materially move. So, what that means across our case study is that in Compose, we really need to analyze the narrative variance and regeneration requests we're seeing from that rep. In Orchestrate, we need to start tracking the escalation frequency and override patterns when things are misaligned. And in ProAct, we need to monitor calibration stability and segment divergence over time. So now that we've examined where this deterministic thinking breaks and I've introduced SHIP, I'm going to apply this across the product lifecycle. Using our ABCRM case study, we're going to cover how these principles will shape the decisions that we make in generative, agentic, and predictive workflows. So let's say that sales rep opens a high value at risk account, and Compose generates a renewal narrative for them that synthesizes the risk drivers and expansion signals that are based on that recent experience of that customer. At the same time, in parallel, or Orchestrate can trigger a retention workflow that will adjust the outreach cadence and escalate it to the rep for intervention. And Proact might surface things like churn probability, expansion likelihood, and segment level confidence. As you can see, these workflows are highly dependent on one another and end up amplifying one another as well. So if we were to experience something like drift or miscalibration or variance, and that happens upstream, its effects will cascade across all of these interrelated and interdependent workflows. So what that would mean is that if the renewal narrative subtly overstated risk, the rep might end up interpreting that urgency differently than they intended. And that will then shift how their next workflow executes, potentially escalating prematurely and deprioritizing more important next steps. And that escalation will then reinforce the data that we're using for predictive signals about account stability and reallocate our focus in the wrong places over time. And that's why when we're designing, developing, and evaluating these types of processes, we really need to account for the compounding effects that exist across these generative, agentic, and predictive flows. So what this means is that we really need to articulate the constraints clearly and the variability that's acceptable before we ship and deploy these things. So when we're designing generative, agentic, or predictive tools, we really need to ask ourselves questions like, what is the range of narrative variance that's acceptable before it becomes distortion and unreliable? How should our users interpret this output? Is it a recommendation? Is it a probability? Are we certain about it? If they're not reliant on this or they have something that they're not necessarily trustful of, how can they interrupt it or override it or even roll back the automated actions and preserve control on their end? And lastly, what success metrics should we factor in that are aligned to our system's behavior and human understanding? So in your own work, this really means predefining what are those acceptable performance ranges? What is the use case specific risk tolerances that we can allow? And what recovery paths do we need and leading signals to rely on that will indicate drift before these outcome metrics are affected? In development, we're usually operationalizing these decisions that we've already aligned on during design for production. And at this point, we need to consider the factors at hand, such as how are we going to detect hallucination or distortion or reasoning breakdown? Have we tested human behavior as adjustment under ideal or incorrect conditions? And are things like drift and requery rate and correction patterns being logged before we launch? So, in your own work, this means really defining these ideal operating zones and enforcing them programmatically and embedding them into our code. We also need to test our inputs and foundational understanding against the entire population to identify what's noisy and what's meaningful. And lastly, we need to pair this with fast recovery pathways. And what this means is that we can enable successful self-service and intervention at scale across these variable and probabilistic outcomes. So after launch, evaluation usually will monitor the system and human interaction through the lens of performance and experience over time. And this means that we need to institute checks for indicators like are the automated triggers that we're firing with intended frequency and boundary ranges that we've expected? Is the user's action and trust aligned with the actual narrative quality and reasoning integrity of the model's performance? And are escalations or override spikes indicating systemic miscalibration or one-off issues? So, in your own work, this really means expanding the KPIs that you're setting for yourself beyond traditional things like activation and engagement and retention and conversion to include things that are indicators of success in a leading manner. So, that can be things like the volatility that's happening within your defined operating bands for your AI tools. It could be things like persistence of deviation over time. How often are things being overridden or recovered and the patterns that are associated with them? And how can we understand if segment level divergence is unique or representative of a bigger problem? So, when this performance appears stable, but the interaction patterns are shifting, instability is actually already forming. And that's the difference where deterministic validation and probabilistic governance really need to vary. So now that we've examined where deterministic thinking breaks down, and I've introduced SHIP, and we've applied it across the design, development, and evaluation processes in generative, agentic, and predictive workflows, we're now going to focus on what you should know and do next as you operationalize this in your own work. So to develop SHIP enablement logic for your work, I'd recommend that you anchor to 4 invariants. First, stability in the average does not necessarily mean stability in the global system that we're orchestrating. And this is because composite scores will often conceal local divergence that's really meaningful. So to counteract this in your own work, make sure that you're defining those acceptable behavioral ranges by segment, context, and time window, and they're derived from foundational understanding of our users, their mental models, their goals, and what's available and acceptable to them. Secondly, our confidence signals and human risk tolerance are rarely aligned by default. And that means we need to separate out what are our calibration gaps from our adoption gaps and start to think about how we're baselining for override frequency as well. Third, volatility without containment ends up eroding agency over time. And since recovery, interruption, and rollback are no longer just experientially driven, but performance driven too, we need to encode these and track these for recovery latency as part of our success metrics. And fourth, drift usually appears as a leading indicator in signals like variance, divergence, and overriding patterns. And this is before lagging outcomes will degrade, like revenue or churn. So make sure you're encoding and monitoring these indicators and then implementing persistence rules, hysteresis logic, and automated recalibration. Because SHIP is only really real and applicable when these rules that we've created for ourselves are measurable, enforced, and continuously monitored. And finally, here's how you can do it right without outsourcing reliability, trust, and outcome metrics to just randomness. So make sure that your acceptable performance ranges are grounded, like I said, in those mental models and risk tolerance and business impact, because we need to understand the relationship of those things and what levers to pull in a proactive way. You should also require signal persistence before escalation, because one anomaly is noise, but sustained deviation is drift, and that's really what we should be focusing on in these systems. Make sure when you're considering how to weight events, not only consider frequency, but also consider harm, because a single high severity misfire can outweigh just hundreds of minor successes in this case. And make sure that you're exposing miscalibration before your lagging metrics do. So monitor agency signals like overrides, rollbacks, and regenerations as a cue of when things are going off course. So if you were to apply even one of these checks to your next AI tool, you'll end up being able to start shipping stable, sustainable, and AI ecosystems. So thank you so much for your time today. If you'd like to learn more about my upcoming work, you can do that here, and I'm open to any questions that you all have.
Excellent. Thank you very much, Bianca. I hope everybody out there enjoyed it as much as I did. And just a reminder, you can write your questions in on whichever platform you're watching this on, and I'll put those questions through to Bianca. But I'm going to start with the first question because it really struck a chord with me when you said that kind of lack of trust. So, for example, Gmail now have an AI summary of emails at the top, and I don't read it. I don't trust it. I don't believe that it's actually going to catch the real meat of the emails. Maybe it is, but I've just seen AIs mess up so much that I don't trust it. So when you talk about that range of, how do you phrase it, the range of narrative variation, can you give an example of how you do that? Because I wouldn't even know where to start with something like that.
Yeah, that's a really great question, Rory. Thanks. So usually when I'm thinking about what is acceptable and what we're willing to, allow to happen in our system, I'm usually starting with three inputs. The first is, how do we think that this system behaves under known and good conditions? And how is that aligned to the expected outcome that the end user is hoping for? Next is, how will that behavior vary across different segments? So in the context of this, it might mean that different profiles have different sensitivity and reliance on the tools that they might be considering. And lastly, I usually factor in, what is the cost of being wrong, right? The cost of a summary email that's maybe misrepresented is a lot different than if we trigger an automatic workflow, to enable one of our sales reps to to course correct something when it's going wrong. So I would say that when we think things are less dire, it's okay to have more variability. When we know things are much more concrete, we need to be much more prescriptive and have a much more sort of foundational understanding of what that user wants, what are the risks associated with it, and that outcome. And I think that's where traditional design and research practices really end up powering AI, because they build the foundations that those models can rely on and mean that convergence in the models happens much faster.
Right, like I'm thinking back of some of the work I've done previously in CRM systems, and it was very deterministic. So it was, if this, then this, if this, then this, if this, then this. So I understand it from that perspective because it's very limited in a range of acceptable inputs.
Exactly.
Whereas with these AI tools, and this is where I'm a little uncertain, is that there is no input range. It's kind of just the whatever the person thinks of. So how do you come up with that subset, as you were saying, of like, okay, let's say my persona is somebody who wants it very tight or whatever, not much variability. How do you go about identifying and then teaching the system about these acceptable inputs?
Yeah, so that's really where you start thinking about those leading indicators of performance and experience that we're not considering right now. So, Rory, if you were to engage with a tool and we were able to see that you regenerate the same input much more frequently than others do, we can start seeing and identifying where that breakdown is happening. If we're seeing that you're taking things outside of the platform that we've established with workarounds and the continuous workflows are not happening, those are all leading indicators that something is not necessarily going well. So what I would say is there's like four things that you can usually do. You want to monitor the output's variance over time. You want to track the relationship between that variance and the override behavior behavior that we're seeing of that end user. We then want to see if those shifts are having meaningful effect on either the ancillary workflows that are tied to it or the immediate next actions that the user is taking. And then make sure that we're using that to course correct and feed the model in a way that it's continuously updating rather than waiting for those lagging metrics to happen, when it comes to renewal cycles or things like that. So that's really what I would say is thinking about it earlier in the funnel, monitoring for that variance, and connecting that to the behaviors that we're seeing in a user's outputs.
So it's kind of like a continuous feedback improvement loop.
Exactly. Yeah. And that's one of the things that's most different than the ways that we currently evaluate our product ecosystems versus this newer approach, which is called Bayesian, and is reliant for these AI ecosystems, because what it's doing is it's continuously taking this data and updating and renewing what we expect to happen. But we need to first give it the structure of what we know that matters. And that's really where those traditional approaches are still really powerful.
Excellent. Well, that actually brings us to time. So it's a nice thing to end on, that it's kind of this continuous improvement, continuously getting better. I guess that's what we're seeing with AI systems all the time anyway as well.
Yeah.
So thank you very much, Bianca.
Yeah, thank you so much.
So that brings us to an end for today. But if you did enjoy the talks that we had today, please do consider joining us in our USA or EMEA conferences in New York and Berlin in May. We'll have 40 speakers, 500 attendees, and the whole concept is around cross-functional teams, so product, UX, design, and dev, because it really takes a team to build an amazing product. So whether you're able to come up with those designs and principles that Juhan talked about, you still need to get them kind of built and out into the world. And the same with all the AI systems, although they are shrinking the size of the teams now. So I just want to thank both of our speakers once again, so Juhan and Bianca, for sharing their case studies with us. And I want to thank you all for attending. And I look forward to seeing you at the next UXDX Online. Thank you.